Welcome to the Sound of Silence. This is ASMR Intros with your host. All you can hear now is the background noise of a 3D printer doing its thing. And that is because I'm incompetent at setting up StreamYard and OBS, so we cannot get the audio out of OBS. And here we go. And now? Okay. Yes, that was a weird intro. It was because when I was doing the setup right before the stream, as I was testing with Austin, we discovered that the audio that comes out of OBS is not being captured by StreamYard, which means the intro video has no music. The other thing is that the audio, because I am doing this with Austin, the audio from the computer is going into earbuds, which means no TTS today. Sorry about that. You can, if you do TTS, I will hear it. Nobody else will. So good morning to everybody. And as I just alluded to, Austin is going to be joining me on the stream today. But before I bring him on, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So I have a big list of people who are... I heard that. I heard, who did that? Tinker did it. All right, so people can be whispering things in my ear that nobody else hears. So good morning to Braze, hang on, Imi, Austin, of course, who is waiting just off stage right now, Mitch, Stephen, two Stephens, Gavin Jackson, Crispian, Sharky, Grant, Any Mules, Technibulus, Don S, Imi, Tinker. I think that's everybody who is in TTS so far. Okay, I'm going to, what am I going to do? I'm going to bring on Austin. How do I do this? I think this is it. Let's see. Yes, Austin appears. Good morning.
Good morning.
Thank you for coming along.
Absolutely. It's been a long 2 years.
It has been a long 2 years. A lot has happened in 2 years. And yes, I'm aware that I shouldn't say this. The audio is out of sync on my video because it's not coming from OBS. So there is a delay introduced. So now that I've pointed it out to everybody, it is going to be so disconcerting. It's messed up everybody's minds. Austin, I know that I think everybody in chat knows who you are. Everybody on Discord knows who you are. But would you mind just giving a brief introduction to yourself and the sorts of things that you work on?
My name's Austin. I'm a Canadian that focuses on product development work. I basically do a lot of what you do, John, where I'm working with electronics, and I mostly try to work on projects that are close to my heart, things that I have a passion for. I try to solve problems that I see or recognize. That mostly sums it up. I've tried getting into streaming more often, which is easier said than done sometimes. Sometimes I get really involved in the work that I'm doing and then totally forget, oh, hey, I could have just been streaming for the past 8 hours, because I am known for streaming for long periods of time just because I get so enveloped in the work that I do and I don't really mind the silences. So people can pop in, say hello, ask questions, and then pop out, and it doesn't bother me any.
Mm-hmm. Tinker just said Austin's primary focus is falling down rabbit holes.
Oh, he's not wrong. Him and I, so we actually live close to each other, but we chat constantly, and we are terrible for each other. He sends me things to track down all the time, and then I'll send him something, and yeah, we make our to-do lists terrible for each other.
Yeah, so you just distract each other. Mitch just asked whether you have family. So what's your family situation?
Nope. Nope. It's
Yep.
just me, myself, and I,
Mm-hmm.
and the
Yep.
grandparents. Yeah. I
Yep.
always call
Okay.
grandma on Sundays.
Yep. Okay, so Saturday night for you, isn't it?
It is Saturday night.
Yeah. Great. So now is a chance for anybody who has been chatting to Austin, like has seen Austin in chat over the last couple of years, who've got questions for him about projects and things. The next 2 hours is your chance to ask any questions.
Goodness
And
knows I
also,
fill up Discord from time to time.
yes, but with interesting things. And the, where was I going with that thought? I just lost it. Evil Deast is here as well. Good morning. So, okay, there are so many different directions we could go from here. The whole reason for getting Austin on today is to have a look at some of the firmware that he's been doing for the air quality sensor project, because the AQS, in fact, I have one right here. I should power it
And
up
then I
so that
have
we can
my
see what's on the screen.
Frankenstein one on my bench.
Oh, okay. Oh, you don't have an actual
Nope.
board.
This is how I programmed it, folks. Metal
Okay.
wires.
Okay, I am going to send you a real one. This will not stand that you do not have one. Okay, so the one I've got
The initial
here,
version of code was done without any hardware, and then I'm like, you know what? I kind of want to debug this a little more. So then I went to Amazon and picked up one of the PMS sensors. Everything else I had on hand because, yeah, if anyone follows some of my stuff, like my workshop is well decked out here.
yeah, you have lots of building blocks and inspiration. I think one of the most useful things that I've done over years, this is my justification for my hoarding behavior, is accumulate a wide range of miscellaneous parts, so that if someone says, can you do X, I go, oh yeah, I need that, that, and that, and I've got these on the shelf.
It's one of the reasons I really like the Quick system from Adafruit, because it makes it so easy to quickly prototype and say to someone, hey, this is what it could do, this is the type of information it can report, these are the types of sensors you can use, this is the starting price points, as a quick way of being like, I can show you a proof of concept of how this would work before going and actually designing the product. And it's also why I like building a lot of test modules. So I have some RFID based projects coming up, and started designing modules for that, where it's really simple for me to put a JST connector on it and plug it into an ESP on my bench, and make sure that the idea can work, and I can again show it as a proof of concept.
And Quick is it exclusively I2C, or can you do other things with it as well?
No, so the standard for Quick is a 1 mm pitch 4-pin JST connector, and then they tell you the standard pinout for it. They have colored standard for it, but obviously, if you're buying generic JST cables like myself, they're not going to come with that color palette, and the color isn't going to affect the data on the wire, thankfully. So
Not too much.
could you imagine having to debug wiring based on a wire color?
Yeah. I'm just thinking of when people say things like that as a joke, I immediately start thinking about how can we make this happen? What can you use to do? What characteristics of the wire could we detect?
Well, I'm thinking about those older coach buses where they were known for wiring it all in the same color. You pull apart a dash because a gauge isn't working, and they're all the same color.
Oh no. I've just been helping my son Tom with a dashboard project, and yeah, so his project is he's building a digital dash for his Honda Civic. So he's got an old Honda Civic.
Yep.
What year? I think it's 1986. I can't remember. Something like that. An EK Civic. And so he's bought an additional dash unit from a wrecker, and we've been going through that and connected up. Last weekend, we connected the oscilloscope into the dash that's in his car and measured the signals coming off the speed sensor and everything. We put the car up on blocks so that we could spin the wheels without going anywhere, and measured the various signals so that we can figure out how to acquire that data into a Raspberry Pi, which will be running a 7-inch screen, I think it is, that he's going to mount into a 3D printed adapter that goes into an original dash enclosure. So
Nice.
yeah, his goal is to build a digital dash for an old style Civic that is a plug-in replacement. So you pull out the old pod, plug the new one in, and it all just works. Yeah, so we've been having fun with that. But that has also involved a lot of searching for wiring diagrams from 1986 era cars. And this was, of course, different cars. The same car sold into different markets ends up with different options.
Right.
And so that you can find a wiring diagram that has the color codes and pinouts for the dash, but then some of them are missing, or there are some that aren't documented in that particular thing because it was a UK version of the Civic. Yeah.
So it's funny that we complain about the wiring on an older car. I was at a car show a couple years back and started chatting with a gentleman that worked at. He operated a few dealerships, and at one of them they had fairly higher end cars. He said for them to try and hire a technician to work on electronics can be quite difficult. Even more so because some of the cars have upwards of 80 modules with no diagrams. And then they change often. So you have to understand how the systems work at a core level to know where you're going to go looking for diagnostics.
That
Yeah.
sounds like a painful process.
Oh, it's definitely needlessly overcomplicated.
Yeah, yeah, and it's a lot of black box reverse engineering, which shouldn't be necessary if it was documented and there was some consistency in labeling and all of those sorts of things. But they are optimizing for manufacturing efficiency, I guess, and continuously changing things. So we just have to live with the consequences.
Yeah, which means a $300 an hour diagnostic fee.
Yes. Don has said not an RX. Yeah, well, he is recently becoming far more interested in rotaries. So this is in reference to Tom having a Civic. No, he's never really been interested in rotaries until just recently. And
don't show him Rob Dom's YouTube channel. Oh, goodness.
Yeah. No, that's right. Yeah, with the 12 rotor or whatever it is from the boat that he's been working on. I know he's done some crazy.
All of the projects that guy's working on are just absolutely nuts.
Yeah. Tinker says, my 75 Civic was a blast until I tried to drive it upside down in the snow. Yeah, they don't work so well upside down. Mitch said, I had a 1990 Civic, did 320,000 kilometers. I miss it. Crispian says, yeah, got to have the tires pointing down.
Yeah, I finally bought my first car sticker last year.
Oh, you did?
Yeah.
Right.
And it's I for the amount of money I spent on it, I've been so thankful that it hasn't been a disaster. And I'm just counting my lucky stars that it lasts long enough before I have to buy the next one. Although I know what I want next. It's just a matter of saving up the money for it. And our used market is going to crap, so it's getting harder and harder to do anything.
So you've only had the car a year and you're already looking at what your next car is going to be.
Well, I knew it in advance of buying the one I wanted. I just knew that at the time I couldn't justify the money. And then the 2025 version came out, and it included an upgrade that I really, really like. So for reference, the vehicle I'm talking about is the Ford Maverick, which these days is a small pickup truck. And so far, there's nothing actively available in my market that can compete with it, especially the hybrid version, which as of 2025 is now rated for the all-wheel drive 4K tow package. Gets
Okay.
half the fuel economy of my Ford Escape SUV, and has way more cargo space. The interior is the exact same size as my SUV, which is intriguing. And it would more than meet my needs, but that fuel economy will be fantastic. And then the maintenance and whatnot on it, it's built as a very simple work truck, and it's quite maintainable. And then there's an online community that's built a program called ForScan, which is basically a OBD scanning program for Ford vehicles. But it lets you change parameters on modules. So it makes that car a million times more repair friendly for someone like myself who has training in the automotive industry, and can do that work myself.
Yeah. Yeah, not working blind is a huge, huge advantage when you have to guess and figure things out as you go. Hang on, what was that? So
That was me
Crispian
getting
just
a
said,
text message.
yeah, that's all right. No, what I'm just looking at was Crispian said, I wondered what that star meant. What is that in reference to?
I
Oh, star
believe
shift.
it's a reference to
Oh,
YouTube
Don's
memberships.
comment. Oh, right. Okay. No, I think he's responding to Don's comment. Early Honda-matic gearboxes had a star shift position used to move off, then you would shift into drive. A star shift position. What's a... Oh, okay. Then maybe a start shift? Okay. I'm confused. Anyway, people in the chat can chat among themselves. I will try not to be too distracted by them. Actually, this is a relevant question. Evil Dees said, I need to pull battery state of charge over OBD2 for a DIY tracker for my van. Any tips where I could find where the IDs might be documented?
Ooh.
So
I feel like voltage is a generic ID, is it not?
well, what I'm not sure about is whether this is referring to the general 12-volt voltage. My suspicion is this is not just for regular battery voltage of a car, like an ICE vehicle. This is battery volt, like state of charge for an EV, and
Right.
that will be different.
Yeah, that would definitely have a very specific parameter.
Yeah, that's right.
And
That would have to be
even
reported.
most generic scan tools aren't going to tell you what address it's reading. The only thing I could think of would be to use a scan tool capable of reading that value, but have the ESP in place to do packet sniffing. Because at least with my scan tool, I can go in and tell it which parameters I want to watch, and that way, if I'm only watching the one parameter, it would make it a little easier. And yes, voltage does not equal state of charge.
That's right. Yeah, and then the update was that it's an LDV eDeliver 9 traction battery. Yeah, so it's not just like the normal 12-volt vehicle battery, it's the traction battery. Crispian said it varies by manufacturer, but is well documented.
Whether or not the manufacturer gives you said documentation.
No, that is a problem. Now, we have another, how long? We've got another 40 minutes before we should get to the point. So before we get to the point, I just wanted
You
to see
did
if
start
there are
the
any.
3D printer, right?
No, I didn't.
Do you want to
I should
start the
do that.
3D printer? Do you think it'll be
Yeah,
done fast enough?
yeah. It should be done fast enough. So what I will do is, let me see. I'm going to. All right. This will be kind of confusing, but let's extra camera, present. Oh, share screen. Now I've got to select which
Actually, it's funny.
screen.
I have one of those launch scan tools. I got mine a while back. Actually, we'll
Mm-hmm.
pull it up. I wonder if I can find. Now I know my model's long discontinued, but
Yeah.
let's see if I can find it in my Amazon order for. So the one I
Okay.
have is the CRP123, and it works fantastically. And then for the advanced stuff, I have my 4 scan on my laptop.
Yep.
Ooh, case design.
Yeah. I'm going to suppress those. So yeah, I'm just going to. All right. I'll explain a little what I'm doing, and then I'm just going to do it without talking about it, and we can continue talking about other things. What I said to Austin just before the stream is that what I was going to do was do a slide update to this enclosure for the air quality sensor to remove the top buttons. And then I'm going to send the enclosure to the printer. So hopefully by the end of the stream, I have the enclosure that I can show you. So that is all I'm doing. Body 1, body 2, yeah, body 1. So I'm going to save that as a mesh. And what am I going to save it as? I'm going to stick it somewhere not there. Where am I going to put it? I'm just going to stick it on my desktop for now. like a, I don't know, a caveman. AQ, not AGS, AQS body. And then I can pull it into Bamboo Studio. Oh, what is currently in Bamboo Studio, because this is what's on the printer right at this moment, is something else that Austin and I can talk about, which is conveyors. This is related to the drive motor for the little PCB conveyor. And I've just, in fact, if I come to device and start the video stream, so we'll have a look inside my printer. Oh, you can just down the bottom there, you can just see the top of it. That is where this print job is that's just finished. So I'm just going to load up. Once again, desktop and EQS body. Yes. And that is the wrong way around. I want to stick it on that face and change it to yellow so that we can see it. So Austin, I'm going to make you an AQS and send it to you. Do you have a particular preference on color for the enclosure?
No, I do not.
Okay. I kind of like doing them in white because it makes it look slightly Apple-ish.
Let's avoid white. White doesn't stay white in this workshop.
Okay, so I could do white, black, yellow, red. I've got hot pink filament, which I use for making spray covers, so
That's
that they
hilarious.
stand out.
Sure, why not? Send a pink one. Let's make this a big live stream.
Okay. For now, I'm going to print this one in yellow, just because it's easy to see on stream. With black things, if you hold them up like this, unless you got the lighting just right, it's very hard to show it on stream. So let's send this one off to the printer. Oh no! First I have to get the alting out of the printer. So, do you want to talk semi-publicly about any conveyor stuff? Because I know, Austin, that the conveyor project that you're working on is for a client.
Oh no, I'm happy to talk about this one. It was actually just before coming to John's stream. I did some streaming as well. And I was working on a little bit of my project. Actually, do you want me to screen share it? Or
Sure. I'm just going to send this to the printer. That one, PLA, yes. In just a second, I'll pull Austin's desktop up to replace this. I can hear the printer starting. It's doing its calibration thing. Okay, so I'm going to get that out of the way and switch to Austin's desktop. I'm going to remove, oh yeah, add to stage, that. Remove, add. Okay, go for it.
It's got a comment about, did you upload the last print?
I don't need to.
Unload the last print. Yeah, you did.
Yeah, unload. Yeah. I have it in my hands right now so that I can do a test fit. So I'll do that in a moment.
So I have a client. It's a nonprofit. They do handling of donations for some of their uses. Most of them tend to be physical items, although they're not the only agency trying to get away from physical donations, just because you got to put it somewhere, you got to track it all, and it's a lot of work for people. One of the things they do and others do is they go through gift codes. There can be times where they'll buy their own gift codes as well, simply from a financial standpoint, because they either have surplus budget or getting not gift codes, the credit codes for managers at times can be complicated. And obviously you can't hand out your credit card to a client either. So if you're giving them a gift or helping them buy something, a Walmart gift code can go a long way. But again, it's when you're talking 10,000 plus gift codes in a year, that's a lot of tracking and a lot of hands-on and people that have to fill out paperwork.
And presumably there is a lot of variation as well, because people who are donating these could get gift cards from any random store or from wherever.
It is a pain in the butt for the companies that do not let you check the price on a gift code online. Mm-hmm. Sitting on hold and punching in numerous code numbers to find out their registered value is so tedious for volunteers. It is so tedious sitting there. Oh, gotta call this one. So you call their 1-800 number, go through their phone tree and put the number on the code, scratch off the PIN number and put the PIN number. Oh, the value is such and such. Write it down and then call back for the next code. There have been times where we get lucky and it's a store that's somewhat nearby, and we'll take the batch of them and we'll go and have the manager just run them all, because otherwise it's like it just takes so much time. But I've proposed an inventory management system, and there's lots of videos on my channel and live streams, and hopefully next year I'll get into it even more and refine the system. So it has custom barcode scanners and a receipt printer that are part of the system. The other aspect, which is what's on screen, is me designing an ATM machine that will handle all these codes. And so the model on screen is actually built up of 3 smaller models because it's modularly designed.
So when you say an ATM, what you're talking about is somewhere that someone can walk up with a random gift card, they put it into the machine, and it's then processed to analyze the card, figure out what balance is on it and whatever else you need to do.
Yes.
Okay.
Yeah.
Do
So
you
I
then dispense the card? Is this in an internal tool, or is it in
yes.
a public situation where
No, it's
someone?
internal.
Okay.
Yeah. So I picked up I think it's a 10.5 inch touch screen, and it's got a nice glass screen um, designed for Raspberry Pis, but it has an HDMI input.
Hmm.
So it's connected to a tiny Lenovo workstation machine. And with help from Tinker, we found all the small little loopholes for locking the machine in kiosk mode so that basically as it boots up, all it gives you is a web page that I can point it at the server for. So it doesn't let you do anything I don't want you to do with it.
Hmm.
Um, and through that, and in combination with the fact that all the staff use an RFID tag for building access, for printer access, and such, that will give you access to this machine. And then there'll be a web page where staff can see the inventory. Through that, they'll be able to group codes for a particular client, and the supervisor can go in and approve transactions. Once it's approved, you go to the office, machine spits out your order, and you take it away. As opposed to the fact that right now there's roughly 8 different people that might be involved in a process of signing out cards. It has to stay in someone's office. You got to hope there's a supervisor on site with a key that's readily available. Otherwise, you're waiting around for it. So it's hopefully going to cut down on hours generating reports, people waiting around for things, cards that potentially sit stagnant because you don't know they're available. Because again, if you're getting a variety of brands, sometimes somebody might just be in a rush and not pick something that's potentially more meaningful. So the core of this machine is it's got a central conveyor belt that sits along the bottom here, using standard off-the-shelf 3D printer parts and rollers and such. Everything has bearings on it so that hopefully it can be durable and long-lasting, but also maintainable and repairable. Trying to There'll be quite a few 3D printed parts, but I'm trying to limit 3D printed stuff to things that can sit statically and not wear down and break as easily. And then with these gantries, the idea is that there'll be sets of shelves on both sides of it, and it'll be capable of picking cards off both sets of shelves. And it will query a database to know where all the cards sit and which way to dispense them. But the idea is a code comes in one way. There'll be an elevator or something on the one end so that codes only travel in one direction, which will essentially allow for an infinite loop, and hopefully faster processing of codes. And to process codes, it leads to this mechanism where you're going to be inputting codes from the front of the machine. So the code essentially has to go 90 degrees, and that's where this turntable kind of comes in. So it's got a motorized wheel here that'll pull the code in, turntable can rotate, and then spit the code out through a ramp onto the main conveyor. And the ramp is high enough that the codes that'll come up from the underside conveyor that's not currently modeled, and this part has to change. It's there as a placeholder to remind myself, but it will come up onto a conveyor belt if it's a code that is actually wants and it didn't misread a code. It can just spit it out and drop it into a hopper for the user to grab, or it can reverse the belt and there'll be an opening on this part to send the code back onto the main conveyor, and then it'll go back onto a shelf. And then the reason these motorized wheels are on these gantries is what I'm going to build as a follower cam onto this turntable, so that as the table starts to turn, it'll lift the wheels off so that they're not dragging against a code or
Clever.
hitting the edge here when it tries turning. It's just not something I've modeled yet because I'm focusing on providing the client with a relatively accurate cost sheet. So I'm trying to find all the parts that I need first before getting into the intricate parts. But obviously, there's a bit of a gap here for code to come in, and so far the machine still can't tell you what the code is, which leads to the third mechanism, and this was what I was streaming a little bit of today, which is I found a model on Thingiverse for a 3D printed conveyor belt. And I thought it was a good design, so I've beefed it up a lot and designed it with a belt drive here. But its main goal is to be able to read a code. So I was telling John this before the stream. The problem with modern gift codes is they can work in one of three ways. There might be a magnetic strip to read. There might be a barcode, or there might be a QR code. It can have any combination of the three. It could have all three. It could have one. It could have two. It could be a mixture. Ideally, for myself, I find the barcodes and the QR codes tend to be the nicest. Not just from a usability standpoint, but the magnetic strip read head is only good for a certain number of cycles. So you also want to limit that cycling if you can. But the annoying thing with gift codes is the only two things standardized on a card is the magnetic strip, the type of data it has, the order of that data, and its position on the card and the size of the card. Those are the only things that are standard. So the problem you run into is if I wanted roller wheels to push the car along a set of rails, the wheels are either going to block the magnetic strip or they're going to block the barcode and the QR code because they can be anywhere on that card in any orientation that the manufacturer decides. If I put the wheels on the bottom, it needs something to push against, otherwise it's going to distort the code. And if I try to put any set of rails anywhere, again, I could end up blocking the data I want to scan. So my best bet is some sort of belt. So I started modeling this belt in a way that it has this pusher arm. And there'll end up being more links that have the pusher arm, so that once the code has gotten into place and it's past all the roller wheels, the belt itself can push the code along into a position that I want. There'll be a magnetic read head that I'll design to actually fold out of the way, so it's only being worn down when it's needed. And then this pusher would just ramp up the speed of the motor to push it at the right speed that it can read. Otherwise, it can stop in a position, and there will be a gantry that sits above that can hold the scanner module that can read the barcodes and whatnot at the correct read distance and be in position, but also move should a code decide to have the codes in a different spot. And this module is essentially what's going to handle codes going in and out. So
sorry, just a quick question. You
No, it's
talked
fine.
about cards being in a different, the read location being in a different spot. How would your system detect that in order to move the read location?
So ideally, I'm going to handle it in a few different ways. I kind of want to build a JSON config file that'll have the various codes, and that can what do you call it? Dictate where it's looking.
Okay.
But
So
even
you would have pre-configured card types. You're not
yes,
talking about a situation where you're dynamically trying to detect where the read location is or the location of a barcode.
I have found even with the readers, sometimes it helps moving it slightly. So like that little bit of jitter would be programmed into it just to help it actually center itself. But in general, I would tell it like, I'm trying to see if I can find one of the codes. Most codes have the barcode along the long edge.
Mm-hmm.
I did see one in my collection here. Like Amazon has started using QR codes. Yes, I'm showing the codes on camera. They have all been used. You're welcome to waste your time. Um,
So Jordan asked whether you're using a camera or a barcode scanner for the QR code.
so I'm using both. I have a camera-based module. It's the same module used in um, my inventory scanner. But I found the camera module has to be way too far away to read the barcodes, especially the
Mm-hmm.
ones that are ridiculously long.
Mm-hmm.
Um, and then this is an example of a code that's put it sideways. Um, so for handling a code that um, uh, has the bigger barcode, rather than trying to build a gantry that goes really tall
Sorry,
to read
I'm just
that,
trying.
um, the same seller sells this one, which is a laser based module. And that can read at a distance of like 15 millimeters away. Um, and and then you have this one, which is a camera based module. This is capable of reading QR codes plus barcodes. But if I wanted to read a barcode like this, I'd have it easily 200 millimeters away in order to read it. And you doing this to try and get it to align, and it won't work. And you definitely won't read the, I don't know, I think it's like a 10 millimeter by 10 millimeter QR code. So you got to have
Yes.
this thing like right up on it.
Mm.
So rather than using one or the other, I found it's just better to use both and have them at a more appropriate height that I can
Okay.
read all the.
Yeah.
Um,
So I can deal with the different situations.
yes.
Mm. Mr. Fixit just made a comment, move the card from the side edges. So I guess that's to overcome the problem of having the rollers and the contacts on the face of the card, which then obscures part of it. Have you considered doing like a side gripper type arrangement?
Um, yes and no. So again, it creates that problem where, so like you can see the mag strip is a set distance away. I believe that's maybe 3 or 4 millimeters away from the edge. If you're lucky, you get codes that are like this, where the barcode is kind of right in the middle. But then you can get codes where instead the barcode is at the other side, and now it's you got no edge to put anything against. Um,
No, I think
which
what I think by edge, I think what Mr. Fixit meant was actually squeezing the card from the narrow edges. So instead of having rollers come down onto the face, have them come in from the side.
again, I
Which would
think you'll still get too close to something you're trying to read.
mm,
And I found, at least in terms uh, of um, what do you call it? Handling gaps between
mm,
belts and stuff, it makes more sense to do it on the long edge of a code when it's moving,
mm-hmm, mm-hmm.
just so that it can transverse those gaps faster and easier.
Mm-hmm. Okay.
Yeah.
All right. That's really cool. I'm just going to briefly bring this up. So this is the progress on printing the AQS enclosure. Where are we at? We're at layer 44 of 131, 58% done. Those two numbers do not seem to compute, but that's because most of the printing was in the first few layers where it was doing the front face, and now it'll rip through the last 90 layers or so pretty quickly. So we will return to that. And the other thing, okay, so there was an interesting edge. Sorry. my brain just did the thing where I was saying something, and as I was reading a comment, and words from the comment ended up coming out in my sentence. So it probably didn't make any sense. Back here, where are we? This one, yeah, from Any Mules. Has there been some merging of projects lately? How about a PMS module that connects to a SQUIXL to make an AQS? I saw this comment earlier while Austin was doing his demo. And so what I ended up doing was my SQUIXL right now is in the process of doing a firmware update. I have the SQUIXL in front of me. And I haven't done this before, but I believe the SQUIXL can subscribe to MQTT topics and display values on screen. You can create a widget. I think that's what it can do. It didn't. That feature doesn't seem to be in the current. Tinker just said in my ear, next you'll be saying what you hear from TTS. He's really trying to mess with me. I'm just a puppet. I will just say whatever people say through TTS. So what I don't know about, because I have not spent enough time playing around with the SQUIXL, is how much of this is widgets that already exist within the firmware, and how much of it is framework that is to allow you to build your own widgets. But I think what I saw at one point in one of the demos was...
It does have I2C,
yeah.
so it could at least read sensors directly. But if it had 2 extra I/O pins capable of RxTX,
but what I had in mind is we could potentially do this right now on the stream, because we have an AQS that publishes to MQTT, and in fact is publishing right now, and then we could sub to that topic on the SQUIXL and have the SQUIXL display the air quality values.
I'd be surprised if people don't have it already subscribing to Home Assistant.
Yeah.
Because that'd be the other option too. Because the firmware is set up to
take that data.
To send that data directly to Home Assistant, so you don't have to do any setup or anything. Once you're in the Oxos admin page,
we are getting dangerously close to the topic here.
There's a button to click, and it automatically enables Home Assistant to find your device.
Yeah. Okay. Well, since we are now, we have now fallen over the topic, totally by accident. I don't know how this happened. This is wrong. It's like Henrik just said in speech in TTS how long the update takes. Yeah, I'm actually a little concerned that something has broken, because it has been sitting in preparing installation probably for the last 10 minutes. There is something wrong. So I think what I'm going to do is take my SQUIXL off. Oh, Jordan said, I was only gone for a couple of weeks. How did I miss whatever a SQUIXL is? A SQUIXL is a project from Sion, Unexpected Maker. And it is a, hang on, I'm going to remove that.
I'll link it in the chat.
Yeah, okay, great. It's basically, it's a square LCD touchscreen. So you can see it's like touch interface. And it's got an ESP32 in it, battery management. There is a magnetic connector on the back, so you can click it onto a charge dock. So basically, it's, imagine halfway between a mobile phone and a tablet, except that it's ESP32 and you can create your own widgets and things for it. And it's got like a magnetic charging thing on the back.
It is very beautifully designed.
It sure is. So the idea is that you can use it as a UI for your own projects or as a desk device. I have mine at the moment magnetically docked on a desk sitting just off to my left, showing weather, and yeah, it's got just the default stuff on the firmware at the moment, so RSS feeds and that sort of thing. But yeah, this is an Unexpected Maker project. and Austin has now linked it. Do we get, Tinker says, do we get to blame Sion for bricking it? I don't know. All right, I'm going to reload this SQUIXL update thing because I don't think it worked. All right, I'm going to do, so this is the firmware updater. I'm going to bring this back up on screen. Sorry, this is deviating from the topic again. I have version something. I don't know what version is currently on it, but it's not up to date. So Austin has this paired, yes, connect. Install SQUIXL firmware. I'm going to do erase device. I wasn't doing erase device last time. I'm going to do that just in case that was my problem. I was trying to avoid having to set up Wi-Fi and everything again. But if that has to be done, it has to be done. So I'm going to leave that doing its thing. And we should start looking.
Broken. The most recent comment from Henrik.
Yeah. Broken unexpectedly, yeah. It is unexpectedly broken. So let's start talking about firmware for the AQS. Now, I did the board layout for the AQS. I had some very primitive firmware that I was using based on the previous Arduino version of the project. And I used that to get the basic functionality working in that I could read from the particulate matter sensor from the VME 680 and report those values to MQTT. But I didn't have the screen doing anything useful. And Austin saw my lame attempt and said, I can do better than that, but in a nice way. And then created firmware, the firmware that is running right now on this AQS. And I will give you a quick demo of this. In fact, can I reach? All right, what I'm going to try to do is move over to my overhead camera. That means because I think I'll be able to show it to you a little bit better over there. Let's see if I can do this without screwing up too badly. So I'm going to switch to that view. I'm going to turn that off and do not that, that. See, I'm an expert. I can figure this stuff out. All right, so this is the air quality sensor with the firmware that Austin wrote. It's just in this enclosure at the moment. This is the previous version of the hardware. The only difference really is that I changed the orientation of these buttons. It's just a minor change, because with this one, what I had was buttons that come up through the top of the enclosure. So when it's sitting on a bench like this, or from your point of view, it would be like this, sitting on a bench, the buttons are on the top. But the thing is that you don't really use the buttons. They're not an everyday thing. You can use them to switch into different modes. And am I giving away? And they report to
MQTT as well, those buttons.
Yeah, yep. But most of the time, they are not something that you want to access. One of them is reset. The other one is just the action button. So what I did was just change the orientation. So the buttons come out the back now. Instead of being right angle buttons that come up through the top, they're straight and they come out through the back. And that's why I deleted the holes on the enclosure that I'm printing right now. So the proper version of this, the next iteration of this PCB, which I have physically here, is with the buttons out the back. But apart from that, it functions the same way. Electrically, it's identical. And what you can see is that Austin's firmware has a border around the screen, which in this case is green, which means that I am in a happy place right now. And it's got some values displayed. Because I had to unplug it to move it over to this bench, it's only been running for a minute now. So it hasn't yet had time to acquire data for CO2e, BVOC, PMS, etc. So we've got 17.8 degrees here, 65% humidity. I'm surprised at how high that is. That is actually kind of high. It's cold outside and it has been raining for the last several days. So it is very wet around here. But yeah, that is I suppose that makes sense, 60.9% and falling. And if certain things go out of healthy thresholds, such as high particulate matter values, the border changes color depending on level of danger. I think it goes to orange and red. Is that right?
Yes.
Yeah, great. So there are thresholds that determine the border color. So if you have this sitting on a desk or on a shelf somewhere, you can glance across at it, and if it's gone red, you know there's something you need to pay attention to. It just gives you a good high-level view of whether the environment is in a good state or not. Now, if we leave this running for long enough, eventually we will see values pop up along the bottom here. The other thing is that it's showing Wi-Fi status as connected, and the Wi-Fi symbol is green. This should now be connected to my MQTT broker, and it will be publishing values coming off this as well, which is also something we can look at. So if I press the action button on the top, it switches to another screen, which is just an info screen showing that so I paused then because Henrik just used TTS to to break my brain. Henrik's comment was, do you have a dehumidifier? Is that bad for electronics if it's so high? I do have a dehumidifier, which is in the cleanish room. So that the cleanish room is kept generally closed. There's a dehumidifier running in there 24 hours a day. And components and things in there are stored inside IP68 rated containers with desiccant packs. So I've got big plastic tubs with reels of parts in them, all stored in controlled conditions. And there are temperature and humidity sensors. There are Zigbee temperature and humidity sensors inside each of the tubs. So they are reporting their environmental values. So yeah. This is showing things like the version of the firmware, what its IP address is, mode. It's got the MQTT topic extension and MAC address, various things like that. So just general information about it. But this is the mode that you would have it in when you're just sitting it on the shelf and using it for general purposes. So that gives you an idea of what it is, what it does. Oh, I should summarize. So it's got a laser scattering particulate matter sensor inside, which is measuring small particles in the air. It also has a BME 680 environmental sensor. Don't know whether you could hear that through the microphone, but the printer has just finished. It's unloading its filament now. So it does particulate matter detection and also obviously temperature and humidity. And then it does estimates of volatile organic compounds and CO2, which I believe are not real measurements. They are inferred measurements that are calculated based on other parameters from the sensor. Yeah.
And so that's why I don't use them to influence the colored border on the screen, because it's considered a
non-canonical value.
So if you wanted to do actions based on it, then you would do it through MQTT to send you notifications or warnings that, hey, we think CO2 might be bad. You might want to open a window or something. Obviously, this is something that could be improved with better sensors or whatever, but this kind of gives you a starting framework.
Yes, and that's why on the screen it says CO2E, because it's CO2 estimated, I think. Is that what it stands for?
I think it's CO2 equivalent or something.
Equivalent. Yeah. Okay. Yeah. And BVOC. What does the B stand for? I don't... Yeah, VOC is volatile organic compounds. I don't know what the B is. So we're getting updated numbers coming through from those now. But at the moment, I'm not getting any values off the PMS.
I think that was one of the... So I have the code on GitHub, but I haven't pushed a release yet. And I think that's one of the things I needed to fix was if it was having issues trying to communicate with the PMS, I wanted it to put some sort of notice there that it wasn't able to communicate. But it might be that it is communicating. and I don't have it properly handling the fact that it's spitting out a 0.
Okay,
So that's
right.
something I need to check.
So what I'll do now is I'm just going to press the reset button and let it go through the reset process so people can see it do that. If I can find that button in there. Where is it? Slightly offset from the hole. Go press it. There we go. So it's reset, starting up, and it will go through its process of connecting to Wi-Fi, initializing the sensors. You can see the Wi-Fi symbol is red because it is not yet connected, and it's now gone green. It's come up with the display, and it's already got data from the BME 680. So we've got the temperature and humidity, and then other values should follow. I'm just going to leave this sitting on the bench right here and switch back to the regular view. And where are we? Back to here and here. So,
Oh man, that's really zoomed in.
That's very zoomed.
That's more than I realized. Can I move it around so that it's at a proper distance or not?
Well, while you're experimenting with that, I'm just going to go and grab the print off the shelf, off the printer. Oh, it looks so cool in this yellow. The yellow filament that I've got is like it's like an egg yolk yellow. It's really deep, rich color. It's not a bright light yellow, and I really like this color. So yeah, here it is. That's the updated enclosure with those changes that I just made.
Oh, I think the driver crashed on that camera. I'll look on my regular camera.
Now, before I can put a PCB in this, I need to assemble the new ones that have the buttons that come out the back, not out the top, because this now doesn't have the holes on the top. But yeah, it's a really nice looking 3D print. It's come out so well. I got a message, installation failed on the SQUIXL update. So I don't know why I am failing to, hold the boot button. Yeah, okay, so maybe I need to put it into boot mode in order to get this to work. This is what happened. So holding the boot button while clicking install. Okay, what I'm going to do is, where is the boot button? It is there. All right. On the back, there is boot and reset. I just wanted to be able to see which one is which. So reset is on the outer edge, boot is on the inner edge. I'm connecting it to USB. I'm going to hold down the, while it's connected, I'm going to hold down the boot button, press reset, and Austin has gone away. All right, so now it is in, yes, Austin is doing something at his end. I think he's had a problem with his something crashing. All right, back to here and connect to this one. Failed to execute. Interesting. Okay. I'm just going to hit reset on it again, let it boot, and then come into, hello. Yep, did you hear the hello? That was the SQUIXL waking up. All right, now I'm going to put it back into bootloader mode. Refresh this just in case and see, it says paired already, connect. Failed to open serial port. So I don't know what's going on with the SQUIXL update. That is odd. Okay. Oh, maybe turn the border brown, says Tinker. What detects Tinker's suggestion needs a specialized version that detects farts. Yes, best not to overuse it. That's right. TTS is playing directly into my ears and nobody else can hear it. Hopefully Austin gets back in here soon. I'm just going to pull up. I'm just getting into Discord to send him a message. And while we're doing that, let's have a quick look. Okay, we're going to chase a squirrel briefly while waiting for Austin to come back. Get that off the screen. And I'm going to go back into Superhouse projects and conveyor. Returning to the subject of the conveyor from earlier. Now, one of the issues that I've been having with the conveyor is trying to get the motors to run slowly with enough torque to not stall. And the way the structure is set up, if I have a look at the conveyor motor mount N20, I've already got the new one open. This is an end cap that I was using previously. So this is what the current version of the conveyor uses. The reason that it is rebaited like this is that it slides into the end of a piece of extrusion, and it has a hole in it to mount an N20 motor, which goes in through the back, and then the motor shaft protrudes out through here. And then a couple of screws go in here to hold the motor in place, and then a back cover goes on. And the wire routes out down through here. So that is the way that I've been doing it for basically since I started this project. And now I need to, computer crashing. Oh no. Austin just sent me a photo on Discord. He's taken a photo with his phone and sent it to me of his computer crashing. Hopefully it all comes back soon. I'm just going to send him a message. Yeah, okay. Just behind the scenes thing, sorting things out with Austin. Now we've got, so this is the old version. Now the problem is when I have the conveyor belt running into the reflow oven moves very, very slowly. Like the conveyor belt is just barely perceptibly moving. And if I run onto it from another conveyor belt, I need to, oh no, Austin just sent me a message and then it decided to do an update. Thanks, Microsoft. So his PC crashed. And then when it came back, it decided that it was time to do a Windows update. Nice one. Poor Austin. So the problem is that if the conveyor leading into the reflow oven is moving too quickly, boards end up in a situation where they get onto the start of the reflow oven conveyor, and then the conveyor that's loading it starts slipping underneath the PCB. And the PCB stays there in a static position or nearly static, covering the board sensor, so the conveyor doesn't know that it is partly off. And Austin's computer balked, yeah. And then other boards that are behind it on the conveyor can catch up and bash into the back of it, and then there's no gap between the PCBs, and then the board sensor doesn't detect the edge of the... Anyway, it all goes really badly wrong. So I need to get the conveyor running slowly enough that it can match or very close to matching the speed of the conveyor through the oven. And what I found was that with the tiny little N20 motors, even with very high ratio gearboxes, they just don't have enough torque to not stall at very low speeds. Hang on, I've got a cough. Okay, that's better. And so I started looking for alternatives. Now, one alternative is to switch from using a DC motor. Just wondering if I got an example of an N20 here. I should have one because I want to show you the difference between the N20 and the O50, which is the motor I've just switched to. So the N20 is just a regular brushed DC motor, like a tiny little hobby motor. It's very small, doesn't have much power, running into a little gearbox. And that's how it gets its torque. It's just a very high revving little motor running into a gearbox in order to give it the high torque at the cost of speed. And the alternative is to do something like switch to a stepper motor. I could use something like a tiny, like a NEMA 8 stepper, perhaps, mounted in such a way that the shaft can come out sideways. What I should do is bring up on screen this, this. And so this gives you a better idea of what I'm talking about than what I was just showing. So what you can see here is the end cap. This particular part has an idler wheel on it, and the motor goes at the other end. On this model, what I've done is I've got two idlers, which obviously wouldn't work. There's nothing to turn the conveyor. Normally there would be there's one with the motor. So this is the N20 motor in the housing, inserted into the end of the aluminium extrusion here. So what I could do is replace that with a stepper, and that would give me good torque control at low, like very good torque at very low speed. I could run it at extremely low speeds or speed it up to get decent speed. But what I've also been experimenting with, this is what I'm doing right now, is experimenting with the next size up from the classic N20 motor, which is I'm just going to pull up a different feed here, which is the there are times when I wish I had a producer. This is one of them. All right, I'm going to do that, bring this up full screen, because I'm going to go and grab an N20 motor. I'm going to go for a little walk because I need one to show you. I'm really surprised I don't have one handy, sitting where all that stuff is for the, where is it? This is my N20 050 box. Yeah, I should have one sitting there, but I think I've put them all away because I'm actually being neat for a change. 5 volt, 100 up. Yeah, it doesn't matter which one. This one will do. So what I have here is an N20 motor, and back to Conveyor. How am I going to do this? I really have to think this through because this camera setup is so strange. All right, I am going to switch to that view. I'm going to remove that. Hey, that works. Amazing. All right, so this is the N20 motor. Tiny, as you can see, it's tiny, little hobby motor with a gearbox on it and the output shaft. And what I found was these. This is called an O50 motor. At least I think it's an O50 compared to this. Now you can see the difference in size of the motor itself, and the gearbox itself is a lot bigger. It's very much the same concept as the little N20 motors that you see everywhere. It's just a scaled up version. This one is a 12 volt version, and it has, I'm not sure what the gearbox ratio is, but I think the end result is that it's rated to a rotation speed of 29 RPM. Is it 29? Yes, 27. Okay, this is my box. I labeled them because I've got so many different variations of these motors that I need to keep track of which one is which, and they're not labeled. You can't tell. So These are 12 volt, 27 RPM. So with 12 volts into it, this will run at 27 RPM. And what I've found is that this will run, if I turn on a lab power supply and power this up, I can run this down in sort of the 1 to 2 volts region, and it's just barely turning the shaft. It's really, really slow, but it still has enough torque that I can't physically stop it. Like it's got a flat on the shaft here, so I can get a pretty good grip on it, and I can't stop that motor with my fingers. That's how strong it is. So going from that motor to this motor is what I'm hoping will give me the torque that I need at the low speed to be able to make the conveyor run reliably. But that means that the end cap has to be redesigned. And so what I did was I took the existing end cap design. I do have one here. Cool. So this is a print of the N20 type end cap. The motor slides in from the back, and then a couple of fixing screws go in here. The cable goes down. This is an old one, so it doesn't have the cable routing. On the updated design, there's a slot down there for the cable routing and a back cover. So that's the N20 style. So I took that, hacked it around a fair bit, and ended up with this design. And it's a single piece. So the model started off as a single piece, and then I created an offset plane and sliced it into 2 pieces for printing and access purposes. And the idea is that I print this as 2 halves, put the motor in the middle, sandwich it together, and then the motor shaft comes out there. And I've done, so far, 3 versions of it. I just started on this last night. That was the first one, which didn't fit very well and had some issues. So if I put that on, you can see that there is a bit of a gap in there. You can just see the silver of the motor coming through. Oh, looks like Austin is back in the, he's back online. All right, I'll bring him back on stage in just a second. So you can see that the fit wasn't quite good. So I tweaked it a bit, and that resulted in this version, which was better, but still not quite there. And I wanted to make some other, it's hard to tell, but if I clamp one side down, there is a slight gap on the other side. It's very close to being the right fit. And I also wanted to increase the clearance on here for the gear that gets, that's a press fit that goes on. And then this is the one that I just grabbed off the printer at the start of the stream. I just started it printing this morning, and the motor sits in there. That clamps over the top. And this one looks like I finally got the fit just right. And that slides into the end of the extrusion with the motor shaft exposed coming out sideways. So my next stage is going to be put a couple of wires on these and substitute these into the conveyor in place of the N20 motors. So now, hang on, I've got to slide back over here, switch to that, and then I can bring Austin back on. Hey, welcome back.
My computer did not like me trying to use my overhead microscope USB camera.
Oh, that's what it was.
And then halfway through me fixing the settings and putting it back, it decided to shut down my GPU and then stalled everything because Windows was immediately trying to move Windows to the GPU that it hadn't disabled.
Right.
And then, so I did a force shutdown, turned it back on, and Windows decided to do an update.
Just at the right time.
So it did that, shut it down again, bring it back. GPU isn't working. I'm like, what in the world? So I'm swapping cables and nothing. Finally get into Device Manager. It had, because it tried rebooting that driver and it didn't like it, it disabled it. So I went in, enabled it. It's like, no, we don't like that. So I kept it disabled. After a while, finally got it to fully re-enable. So now everything's working. But The closer the Windows 11 10 deadline comes, the more this setup has been glitching on me, which is
Mm.
very annoying.
Mm-hmm.
It also doesn't help that Fusion 360 has already given me the warning that come next January, about a month after that Windows 10 cutoff, Fusion 360 will not work on Windows 10. You have to upgrade. Um,
So
and
it's
I
coming. It's coming.
and I've already tried on this machine to use Windows 11. It's way too slow on this machine. So
Mm-hmm.
I've spec'd my next build.
Mm-hmm.
I now have to fund said next build
Yeah.
because it's not cheap. I don't need the specs I'm going for. I just want the specs I'm going for.
Mm-hmm.
But I have to pay for those specs.
You have to cover
Um,
yourself into the future a little.
well, that's what I did with this machine, and this machine's been very rock solid. I've been very happy with it. Um, so the next machine I've specced out is about $2,800, and that's not touching my GPUs. Um, I might eventually do something with the GPUs. I have a few in mind. Uh, Absolute overkill, um, but also paying the pretty penny for them.
Mm.
Um, but because I have a few different programs that uh, I think they can run on Mac, but I have no intention of switching to Mac.
Mm-hmm.
But I know it won't work on Linux, which is a little annoying.
Yes. Yes, that is very frustrating. There are yeah, okay. I'm holding myself back because this is a rabbit hole that we could definitely dive down, and I don't want to get into that whole conversation. Yeah, it's kind of odd that there are certain, and now I'm going to do it, and now there are certain programs that that I'm surprised to find run fine on Linux, and then others that I wish would run and just don't. They're not available.
Right.
So yeah, it's
You had asked
real
earlier
mixed.
what BVOC is. BVOC is breath VOC, which is volatile organic compounds found in human breath. These compounds are essentially chemical fingerprints that can provide insights to a person's health, metabolic processes. Analysis of these VOCs have emerged as non-invasive method for disease detection and monitoring.
Hmm.
Basically, I imagine if you did enough tuning on the AQS in terms of what you're running, either within Node-RED, or I'm sure there's a way to do it within Home Assistant, you could probably discern when human bodies were within a space.
Hmm. Yeah. Okay. Well, maybe now that it is nearly 1.5 hours into the stream, we should look at the topic, which is the firmware that you have created for it. Should I bring it up on GitHub, or would you like to do it so that you can control driving through it?
Um, yeah, I could probably do a screen share of it.
Yeah, I have it up on my screen as well, but if you're going to be talking about it, it's probably better for you to be driving it. Otherwise, I'll be jumping around.
So post the link in chat.
Don S, thanks for coming. Sorry, Don S just posted that he's got to go.
Oh no! Have a good day.
See you, Don. Yeah, so Austin has just posted the link to the repo on GitHub if anybody wants to follow along and check this out. All right, so if you bring up your screen, once you're ready, I will add it to the stage. Jordan says, I was working with a company that was trying to do some serious breath analysis using a mass spectrometer. That's interesting. For what particular purposes, Jordan? If you don't mind putting something in the chat, that I would be curious to see it. Austin, any chance you could zoom in, like increase your font size or something, just to make it? Yeah, that's good. Thanks. I can read that now.
Yeah.
Yeah. Oh, Crispian says, I think YouTube changed the naming convention for everyone. No, I think
yes, it's
that is.
so annoying.
Oh, is it YouTube in general? I thought it was
Yes.
just because. Oh no, that's annoying.
Yeah, it's using everyone's usernames instead of the
Their channel names.
longhand names.
I thought that was just because we were going through StreamYard today, but
Maybe that
no.
is why. It might be.
Yeah. So at the moment, this is going through StreamYard, which is connecting to the YouTube API, and I'm seeing all of the chat through StreamYard. So it could be that it's using the YouTube API and displaying the username instead of the proper name. I don't know. Anyway.
So our firmware, I figured for cross compatibility and general ease of use that I would tie this project into the OXRS project, which mostly, even though the name is Open Extensible Rack System, mostly what we've boiled down that system into is a really nice set of libraries that can handle background tasks on MCUs, along with other aspects of handling. But it just simplifies connections because this offers both a REST API with a JSON schema, MQTT handling, Wi-Fi handling, Ethernet handling. It simplifies a lot of things. It simplifies how devices work. It makes other devices that you build cross-compatible really easily. So I thought it was a great way to make everything kind of work together. And then with a somewhat recent introduction of a library for Home Assistant, it gives it really easy access to build things. So kind of starting right off the block, declaring the library. So obviously I'm programming in Arduino IDE, but I'm using Platform IO within VS Code. Scott finally got me to transition over quite a few years back. Thank goodness, because I think it was the Smart Hub project that was finally like the breaking point with its ridiculous number of tabs and absurd amounts of lines of code. That kind of forced me to switch over and learn how to do it properly. And I really enjoy how it offers debugging and stuff. But then because of the push button to make it easy, between myself and a few of the other programmers for the OXRS system, we added GPIO handling to the one library because it's the main library we use for handling the OJ45 boards with the MCPs. And then, of course, as I already mentioned, we have Home Assistant. And then I'm declaring that so because we have libraries for the various MCUs, whether it be your D1 Mini, a regular ESP32, and now an S3. This is not a library we've published to GitHub just yet, so it's running locally, but that will end up on GitHub at some point. Modified our 32 library to work specifically with an S3. We're using SPI for the screen, Wire for our I2C sensor. The BME writes a small amount of data at EEPROM and has its own library. And then there's a library for the quality sensor. And then I've made my own generic variables for setting data. These are just defaults, things that you don't need to change. I guess I should mention one of the great things with how this is set up is that you really don't have to do a lot of modifications to this code, if at all. You can uh, once there's a bin release, once there's a bin release on GitHub, you can just flash that right to the chip, and it's done. Now, obviously, someone will notice here there's a default telemetry rate, and then there's a max rate. And the reason for that is within the admin UI, it provides the ability to go in and set what rate you want data to come out from it. You can set both how much MQTT data is coming out, but also how often the TFT itself updates. You can change your temperature data. The big thing to note for that is if you want data going through Home Assistant, make sure you adjust that parameter before telling it to find Home Assistant, as it will send you ridiculous data with the incorrect temperature until you reconfigure it. So just be aware of that. We have our extra resources for the BME sensor, and then its list of things that it's watching for. There's more things you can get from it, but these were the main things that I felt were appropriate for an air quality sensor. And that it's just, so this is part of it saving data to the EEPROM. So you'll notice in between the CO2e and BVOC is a symbol. It's a circle with a question mark in the one corner and our favorite pound symbol, or hashtag as it's now known these days. But it changes color. So when it first turns on, that symbol will be red, and the reason for that is the BME spits out this number here, which is how accurate it considers itself to be. And so when it's at a 0, it considers it really inaccurate. So to save bad data from going out, I just don't show anything until it comes up at least one level, and it will start to show some data. And then as it calibrates itself, it takes roughly, I think, 20 minutes or so before it'll reach green. And once it does it a few times, it tends to calibrate itself faster for other restarts. But that's just there to help you gauge how accurate the sensor is. And then the border is dictated by the PM values, which I'll kind of get to. And then this is where we're saving various bits of data for a bunch of the timer millis assemblies. Saving PM data, float values for the displays. This is for Home Assistant. This helps it build its auto discovery payload.
Interesting. So I was actually wondering what that was. I'm just going to do a very quick switch to my screen share, and then I'll come back to yours.
Yep.
So this is the terminal. This terminal is the MQTT subscription to the AQOS, which is running on my bench right now, and you would have seen it just got another update. So we've got JSON here, so we've got temperature, humidity, CO2, BVOC, and IAQ accuracy. So this is the number that
max.
Yeah.
3 is good.
Yeah. What we are not getting still is the PMS values which I haven't, which it was doing this morning in my room before I unplugged it and brought it to the office. And since then, I haven't seen it do it. It could be that because I've been physically moving it around, the sensor might have become unplugged or something strange may have happened.
I'm guessing. So if it's not reporting anything, it's because it's not getting data.
Yeah.
So
So
the plan is to have it put dashes on the screen so you
Yeah.
know it's not getting data.
So just scrolling back here, this is the point where I powered it up on my bench a few minutes ago, however long ago it was. And you can see that there is this publication in the adopt topic, and it's got a whole bunch of information in here, which is describing, and hopefully I'm not doxing myself by showing
No, it
passwords
doesn't
and
show
things in
any.
there. No, doesn't show any private stuff.
Yeah.
So this is declaring a whole lot of information about the device itself,
Yes.
including things like labels for different attributes.
So what that's used for, that's part of the OXRS standard. And what that's used for is the JSON schema for the admin UI. So the admin UI can connect to an OXRS device through the REST API, and it'll request that payload, which then builds all the input fields so that it knows, because every device is different. So that's the very easy way of it building a UI on a web page to add the input fields that you for parameters that you can change, whether they're config parameters or parameters used for command messages, which would be two different MQTT topics. And that's why that payload is so large and descriptive, because it's essentially building the website for you.
Yes, that's very clever, because it means that the admin interface or the admin system doesn't need to be updated to support new devices. It automatically gets support because the description of the device comes from the device itself.
Yes.
Nice.
So yeah, this declaration in mine is this is everything that Home Assistant wants to see to know how to create a new sensor. So basically, this is your YAML file made simplified. And then we're going in, declaring all our various libraries and their elements and callbacks. And then we jump into loading the state from the BME through the EEPROM reading. This is why it's reading and writing. So it updates its own state when it has good accuracy. So when you first power it up, you let it do its full build up before it will save to EEPROM, and that way
can you just clarify? Sorry, I was going to say, could you please clarify what it is using the EEPROM for? Like, what information do you want to be persistent across reboots?
It's saving its own internal data, something it's doing for calibration. So the reason that accuracy number takes a while on boot and why that logo stays red for so long, but even it'll go to orange and then eventually green. The reason it takes so long, and oftentimes you'll see it jump down again, is because it's trying to build its own calibration. So in order for it to do that, it looks at the EEPROM for previous known data on itself. So once it's able to actually save something to EEPROM, it helps it recalibrate the next time the sensor is turned on, and so on and so forth. And that's why it's using the EEPROM, is so that it calibrates itself and keeps itself in a more accurate state.
Okay. And so you don't want it to have to do that from scratch every single time. So having that data stored in the EEPROM helps with that.
Yeah, so your first boot can take the longest, and then subsequent ones tend to take less time, unless the environment is particularly dirty when you're booting it, in which case it'll be like, hey, this environment's different, I'm recalibrating now, and it'll take its time. And then we jump into our MQTT payloads. So this is setting the schema for the commands that you can send. So you can send commands to wake up the TFT screen. So this is what builds the admin UI payload, as well as it helps build the payload for MQTT. And then the other one is you can tell it via MQTT to switch the screen that's on it. And then because there's a bunch of functions for the ESP in general, we link our custom library so that various things don't need to be retyped out in the program every time. You just add the one line. Then we have the actual processing of an incoming message. So this processes the message. So we're looking for a JSON message that has the term backlight and the expected payload is true or false. And then it runs a routine. And same with calling next screen. It'll run 2 routines in this case. It'll make sure your screen is actually awake so that you see it, and then it'll show the screen that's being called. We jump into our config schema. So there's quite a few things you can configure on this device. You can set how often data is published. Defaults to, I think, 1 second. Yeah, 1 second is how often it is sending data. You can update how often the screen updates. This is the big one, temperature offset. So every BME is going to be slightly different, so you'll have to compare your values to a known value. And it goes to 1 decimal place. So you can program an offset, and then it keeps itself fairly aligned. I find it mostly accurate. As accurate as the sensor is probably going to be. You can set if you prefer Celsius or Fahrenheit. No activity, seconds to sleep. This is what times out the screen after a given delay. 0 is disabled, and then you can set whatever you prefer so that you're not burning out your TFT very quickly.
You can is there a particular way to what mechanisms wake it up? Is it ever woken up by changes in state or anything like that?
Yes, it will wake up based on a red alert state change.
Okay.
As well as you can push the button on the screen, or you can send a message through. Actually, I'm trying to remember now. I think if it goes orange, it'll briefly wake up. Hopefully, you catch it at the corner of your eye, kind of thing. But it will go back to sleep. But if it goes red, I'm pretty sure it stays on until it goes back down. I think it'll stay on while it's red, but I would have to double check the code on that.
Yeah, I have mine with default settings at the moment, so it is staying on permanently because the minimum is set to 0, I guess. But I could change that too.
Yeah, I think default is to stay on. Yeah, default's to 0.
Yeah, so it's my night light at the moment.
And then there's a max brightness setting. So you can decide how bright the display is. Default is 35%. And then it won't go lower than 1. But this is essentially what its on brightness is. So if you have the timeout set, it'll go to 0. But as soon as you hit the button, it'll go to whatever your max brightness is set at. Your next is the button. So it offers a way of controlling it. So the button will report data to MQTT. Its default behavior is that a single button press will not send anything to MQTT. It will instead work purely locally and tell it to change to that config screen where you can see the data.
But I've just tested, a double press event does get reported to MQTT.
Yeah. So it'll work all the way up to penta, which is 5.
Yeah.
Um, and then, but what your option is through the admin UI is that you can set it to purely MQTT control. In which case, that single button press will no longer change that screen directly, but it will send a single press through MQTT, which is why there was that function earlier in the command JSON here, where it lets you select next screen. So if you still wanted to be able to see that screen, you could still control it via MQTT rather than locally for whatever reason you choose to do so.
Yep.
And then the next set of elements, and this one actually builds an array, which is why there's so many elements declared here. This is for your ranges that set when the PM values change for particles, and the color it will trigger within the border. So each element, so your 1.0 has a range, and then your yellow has a range as well. I based it off of the common values you find online. So the default is for red warning on 1.0 is 20 micrograms per meter cubic, and then yellow is 8 micrograms per meter cubic. And then it kind of goes through all of them. So you got 2.5 at 35 for red, 10 for yellow. The 10 is 50 and 20, but these are programmable. So you can set what level these change at if you so desire to do so. More sensitive, less sensitive. And then as each value is changing on the screen, the text color will change as well, so that you know specifically which value is being triggered beyond its set parameters. And then as they're changing, they're also changing the border color with them. And then we're also setting the schema for Home Assistant and pulling from our basic library. And look at that, I got a spelling mistake. I'm using the wrong device name there.
Yeah.
And then we jump into our JSON processing, which is basically taking all that human readable admin UI code and turning it into now we have to read the actual JSON payload to process the data. So it goes through and it looks for the various parameters and set mins and maxes. It does string compares as necessary for various elements. So it just goes through and processes the data.
Okay. Well, since you've just been talking about configuration, I'm just going to switch back to my screen again and show the other side of what you've just been talking about. So with the configuration, this is for those of you who haven't seen it, this is the admin interface for the OXRS. And what I've done is just loaded you can see that it's loaded off my disk. It's just a local index.html file. I've put in the IP address of the AQS, which is sitting on my desk, and I can get the IP address from the LCD. You select what action you want to do. In this case, I did view system, so it loads parameters, and we can see this is data coming off the AQS right now. So we can see it's got a 4 meg flash chip, etc. We can see various other things. You can do resets. And this is the part that Austin was just demonstrating with the configuration. So if I go into edit config, the admin interface here has no idea of what the config options are. All it knows is that this device has configuration that can be edited. So if I select that, all of this user interface, such as this title, the description, the field here, all of this is defined by the device itself, and that is what has come through from this big chunk of JSON right here. So as the device starts up, and then later when it's requested, it can respond with a list of all of its user interface elements, and it is then displayed on this page. So what I could do is change values in here, and that is then saved back to the device into its configuration. And this is what we were just talking about a moment ago with the timeout on the screen. I don't have a value set in here. It's using the default that is configured in the device in the firmware, which is 0. So I could change the screen timeout in here. In fact, I'm going to do that. Let's make that, what is this reading in period of inactivity? So this is number of seconds. I'm going to make it 60 seconds so that it times out after a minute. Max brightness, default 35%, local button control. So this is interesting because these others are text inputs or numeric inputs. This is a drop down with options, and the options have been defined in the interface definition as well. So just the fact that there is a drop down here with options that I can choose from is being defined by the firmware in the device.
You can even set parameters that are like required. So like it won't let you submit the form until you've filled everything out.
Yep.
The other cool one, so you have that drop down menu, the next one after it, which is the warning labels. That one builds an array, and that's why it has that big plus button to let you select a whole bunch of things. But the array has limits, which is why it only lets you do it once. But you go to a device like my LED driver board, it will build multiple arrays depending on how many light strips you need to configure for it.
Yeah, that's really neat. So it makes this management system very flexible. You can define it in your firmware on the device, and then the user interface adjusts to match. Now you can see here I've got a BME temperature offset of 7.3, which is a big offset. I don't know where that number came from because it's a long time since I looked at this project. It's quite possible that I added that value and configured it at some point in the distant past, and I've just forgotten about it. So I'm just going to save that, which will write this configuration to the device. And up here it says successfully updated your device. And yeah, you can send arbitrary commands, do firmware updates. So this is commands that are defined that I can send from here, like waking up the backlight, next screen, restart. These are things that Austin was just talking about a moment ago. So yeah, that's the end result of the code. I'm just going to remove myself and bring Austin's code back up.
Yeah, so our next element is we're actually building the payload for Home Assistant discovery. So it builds the various items that it expects in its template and all the data. And then this is why I said like you want to set your temperature units before telling Home Assistant, because it's pulling it right from here. And then once it publishes, once it has built all the data, it'll send it off to Home Assistant, and you can find it in Home Assistant. And it works fairly well. It's actually very, very handy. You don't have to sit there writing YAML code for your sensors.
Yeah.
Tabraze heading off.
Oh, Tabraze. Yes, I know Tabraze is in a terrible time zone for this stream, unfortunately. It's probably something like 4 a.m. for Tabraze right now in Estonia.
Ooh.
But Tabraze, thanks for staying up late and coming along to the stream.
So the next is this is a helper script for the push button. The one that I had totally forgotten exists for the push button is it can send hold and release events. And these match the same payload you would get from the OJ45 board. So any code you're using for that to control a light or fan or whatever, is all the same for this. So it makes it easy to integrate devices across, which is the whole reason for using it. So as you can see, you got hold, release, single, double, triple, quad, and penta. And then the next is, once it knows the type of button press, it can create the payload to publish to MQTT. And before it does that, it decides if you're doing local control. If you're not, then you can send the single event presses as well to MQTT. And then it's got the actual input handler that runs when it detects a button has been pushed. For values, this is me doing decimal point rounding for better accuracy and better storage of data. To start off a device when it's booting, it runs this nice helper script where it can run through. What we do is we send it an address and a name, so that as it prints to serial, it tells you, hey, one thing we started doing in the OXRS code is we'll add this bracketed name to the beginning of a serial line. So if this was in a library, it would have that library's name instead, so that you know where a serial command is coming from. So in this case, it's part of the main script, so it says main. In this case, it's going to print 0x and then the actual hex address that we told it we're scanning for. And then it will try to scan for that device. If it finds that device, and we're like, cool, we know it's there, so we'll print out the name of the device. Otherwise, we can say there was nothing there, so we know there was an error.
Very handy for debugging.
Which is handy for debugging, but this also will then send back, because this is not a void subroutine, but rather a bool. So we'll send response of true or false when running. We also have ESP info that gets printed on boot up, so it tells you information about the chip ID, the number of cores, flash size, PS RAM, and RAM size, which is just handy to know about the chip. The number of chips I've expected to be a certain value, and then I'm wondering why it's not working. I'll run that through it and find out why. And then we get into our actual code, which is our setup, because it takes a while for serial to kick in. We run a little bit of a delay, start the serial, wait a moment, and then start spitting out data. And then we let the EEPROM start up as well, print out the ESP info, and then I'm running my library for the TFT, which in this case, to make the graphics all nice, we're using LVGL. And then we set...
This is one part of the code that could be of interest to a lot of people, because dealing with the TFT can be very challenging. I've had lots of problems trying to get TFTs working.
Oh, just watch
Arduino.
My live streams from the displays for my scanners. Those have been a lot of fun. Actually, one of the things I plan to do for future stuff is to make that screen easier to configure, especially because I do have a second agency that wants to buy the device. They might have different inventory requirements than another client. So my plan is to actually reuse that JSON schema system to help build all the various input options on the TFT, so that I'm not sitting there writing half a dozen inventory options. It's just one script, and it builds the buttons for scanning and such.
Very nice. I like that.
So that'll be a fun thing to work on. But LVGL can do a lot. What's hard is understanding how certain aspects are implemented and how to better utilize those elements, not only across multiple screens, but also how to build arrays out of things and not have to just manually build everything every time you want it to do something. Because that's when you start eating memories, when you're manually building everything, every iteration, every time you want it to do something, versus having relatively static elements that you can update.
Mm-hmm.
So that's a fun part, and that's part of why I put this in its own kind of library. Is it just allows me to keep the code segmented and make it a little easier to read human wise.
Mm-hmm.
But we kind of jump into setting the pins for the PMS sensor so that it turns on. We start communicating with it, and then we try and make sure that it actually works. This is where some debugging is going to need to happen in the future. But this is where we start up that I2C address, and we start using that subroutine where we're scanning the address for the BME. If it returns, in this case, it's wrapped around an if statement. So if it's true, it will now kickstart the BME's library and actually start up the chip and then start communicating with it, making sure that the chip is actually online and working properly. In which case, we tell the library, hey, we have found the chip, everything's good, let's start working things. So that we're setting the config, we're loading a known state into it, we're telling it what sensors we want to watch and at what rate we're watching them. So you can change accuracy and stuff, but I found this to be kind of the good middle ground, which is what it's set to right now. And then obviously if it has issues loading its status, then it says, hey, there's an issue with the chip here. And then we start up our button. We start up the library to monitor the button and its events. We start up the core OXRS library, in which case it's going to start up Wi-Fi or Ethernet if the device has Ethernet instead. It's going to set your config options as well, your MQTT, all that. It just runs in the background. And then we're going to set up the data for self-adoption and whatnot. And then we get into our loop where we let the main hardware do its background tasks. We double check the input state and process it every once in a while. We double check if there's new data from the PMS sensor. If the sensor.
So just a question of clarification about that. You check whether there is new data.
Yes.
Is the communication from that happening asynchronously? Like, where is it actually doing the receiving the data from the PMS? And just to clarify for other people, the PMS, the particulate matter sensor, has a serial interface. There are also versions available with I2C and other things, but we're using serial. And what it does is periodically send sets of data that you can receive over a serial port and parse. So that's what's happening here.
I believe it checks for so this is the actual routine from the PMS sensors library. So it's checking if it's been initialized already, checking if there's any data, and right now it says false. Oh, actually, no, this is setting data as false, so there's no
setting
data.
the flag.
Then it's checking if there's serial available, and it will read that serial data into a buffer.
Yeah.
And then it will compare that buffer size to make sure that it's not malformed and adjust itself from there.
Yeah, and then just sticks it in the buffer. So that function would need to be called fairly frequently just to make sure that the buffer is being read and flushed.
And that's why you'll notice there's no delays in anything.
Right.
It's just running continuously in the loop. So it's not wrapped in anything, and it can just continue to run. And then once we have new data, we'll say, hey, we have the device, and I grab the data from the library and save it locally. Same with the BME sensor. If the BME is active, then it starts running through and gathers data and saves it, and then rounds things off as necessary, or converts it to the good old freedom units. And then we run the Millis timer for knowing when things need to be updated. So like a TFT, it checks the Wi-Fi status. So the Wi-Fi logo there will show if it's connected to Wi-Fi, but also if it's connected to MQTT. So when it's connected to nothing, I believe it's red. Once it connects to Wi-Fi, it'll go orange, and then once it has MQTT, it'll go green, and it'll stay green for as long as it stays connected. But it also grabs from that helper library information about the MAC address, IP address, MQTT topic, and hold on, I'm being texted. Who's texted? Oh, they texted over an hour ago. Oh my goodness gracious.
Delayed notification. So just while you're checking that, I'm just going to switch back to my screen briefly to show data coming through. What I did was pulled the PMS out of the enclosure and reseated the sensor. So I pulled the whole AQS out of the enclosure, reseated the sensor, powered it back up again. And as you can see, I'm now getting data from the particulate matter sensor. So I'm pretty sure it was just a mechanical problem with the sensor not being plugged in properly on the PCB. But at least this way people can see, yes, I can get particulate matter in 1, 2.5, and 10 increments. So these are the binning sizes for the statistical distribution of the particles in those different sizes. So I won't get into that right now because that's not that's not the important thing right now.
And then we go through and we start sending all that data to the display so the display can show it. If the sensor data is available, it'll send those as well. This is where I need to handle the PMS data when the PMS is not responding, so that hopefully it's more clear that, hey, there's an issue with the PMS. It's not just sending erroneous values. Because so the values it's pulling are internally calibrated values, which is why oftentimes it can set at 0. So like mine's been running most of the stream. Occasionally the 2.5 will hit. The PM10 will waver from time to time, especially if I start standing up and really moving around and moving the dust around. But a lot of times, yeah, it can sit at 0 in a relatively clean room.
Yeah, that's right. So you need to distinguish, does 0 mean that there is no data, or does 0 mean that it is reading 0? And that is the critical differentiation. Yes. Yeah, you don't want it to show all zeros and make you think, hey, I'm in a perfectly clean environment, and it just means you don't have data.
Yes.
Also, there was a quick question. Tinker asked, does the enclosure have provision to brace the PMS in position? The short answer is no. My plan for that is for the PMS to be attached to the PCB with thin double-sided tape. The thing is that because I've been messing around with this, this is my dev version essentially, and the PMS is just sitting on the PCB. It's not properly mechanically attached. And that's why the connector came off.
Almost wonder if it's worth switching to there's a variant of the PMS that has a JST connector. I almost wonder if it'd be worth switching to that with a flying lead.
Yeah, and take it to the PCB. That could be worth checking out. Yeah,
because that'd be more reliable than the itty bitty pin header they put on the thing.
It's tiny. It's such a small header, and that's at the moment that header is the only thing that is attaching the PMS to the PCB, because I haven't actually adhered it in any way. But intention is that they will be attached mechanically.
Yeah, because
Just
mine came with the mating socket for it, and that's what I soldered leads to. And I don't think it has a very good grip on the actual pins internally.
No, it doesn't. It's quite a loose connection.
And then at the very end of this loop, we're telling the display to actually push the update and then resetting our timer. And then we jump into our next timer, which is for telemetry out to MQTT. So it just goes through. If the sensor exists, send the data. And then, yeah, so this will need to be updated as well because you don't ideally want send zeros when it's not a valid payload. And then this is it adjusting. Yeah, so it only sends data if it's above the 0 threshold for potential accuracy.
Okay, so
well.
so at that point you should be getting some data. It won't be all 0 values.
Yes, yeah. So at this point you're getting values once the accuracy value is above 0, which is why these are 0 because you're considering them invalid. Although I can probably just remove them from the payload because I was thinking people are probably going to have graphing going.
Yeah, so you'd have the chart suddenly drop to 0 when there are no values available.
Yes.
Yes, a null is possibly better in that situation.
And then it will publish that data, but it makes sure that the data can actually publish. Well, one, that we make sure we have a valid JSON string to send. And then behind the scenes, it will make sure that it actually publishes and that the connection was valid. And then we're just doing one last minute check to handle anything Home Assistant based if we need to.
Yeah.
But that's the core of making an air quality sensor with a nice little UI going.
Yep. Well, that is very interesting. Thanks for showing that, Austin. And one thing I was going to ask you about is that I've noticed this is something that is very hard to pick, but there is a tiny fan inside the PMS which is used to circulate air past the sensor. And one of the techniques that is used in some air quality sensors is to shut the fan off, or basically to put the sensor into standby mode, because they are, when you're not taking readings, because they are only rated to a certain number of hours of operation because of the little laser exciter that's inside it. And I don't think there is any sleep functionality in the existing code.
No, there isn't, and that would not be something that's hard to implement. By the way, now it's just reading so often that it'll be basically continuously sending you that data. But yes, we can. And that's the bonus of how modular it is. It's not a very difficult thing to adjust going forward.
Yeah. Yeah, I think that would be a nice thing to do. The reason that I realize this is because I have my AQS sitting essentially on the bedside table. It's quite close to me when I'm in bed, and when it's very, very quiet, I can just faintly hear the fan going, but it is so imperceptible. It certainly doesn't keep me awake. It's barely perceptible. And it actually took me a little while to figure out where the sound was coming from. But it just made me realize that the AQS currently has the PMS powered up and sampling constantly, rather than putting it into sleep mode and then powering it up. But one of the tricky things about the PMS is that you can't just wake it up and then take a reading from it, because what it needs to do is stabilize. the usual approach is that you start them up, run them for 30 seconds, which allows the fan to run for the air conditions to become stable within the sensor, take a reading, and then put it back to sleep. So that is one of the tricky things with dealing with it. You need that wake up period before you take a sample. So you have to know that it's been woken up for long enough that you have valid readings from it. So I think I had provision for that in my original code. Now, Tinker was just asking about something, and I'm going to do a quick screen share here. So this is, there was some discussion in chat about the support for the AQS, and we were just talking about switching to an alternative. Where's the enclosure? So if I make the enclosure go away, this is the structure. This is actually for the previous version. It's not the most recent version. So this is the 4.0 version, which has the vertical buttons on it. You can see the mode button there that protrudes, and the reset button that is designed to be accessed with a pin or something. That blue big blob in here, this is the particulate matter sensor, which is attached to the PCB, and then there's the display in front of it. So if I switch it to its normal orientation, and unfortunately the lighting is not, oh, it doesn't want to pivot the way I want it to pivot. Come on, go that way. No, it won't do it. Okay, so the rotate like that. No, I'm trying to get it onto that that edge. I'll just get it like that. All right, so if I hide, so that's the PMS, and you can see down in here, that is the tiny little connector that it plugs into. It's an IDC header, but I think it's 1.27 millimeter pitch, or maybe, or is it, no, I don't think it's 1 millimeter pitch. It's not quite that small, but it is very small. And it does, as Austin said, it does not have much of a grip into the pins that are in the PMS itself. But the way the current design works, the LCD sits on top of the PMS and pushes against the front panel of the enclosure, and in turn pushes against the PMS. So the PMS is sandwiched in between the PCB and the LCD. So in theory, it shouldn't be able to pop off this connector, but it really doesn't take very much movement. And the problem is that with this one that I've been playing with, my test unit, I've been moving it around. I haven't had the back cover on, so the device wasn't actually pushed against the front panel. Yeah, it had everything going against it. So that's why the PCB had moved back slightly in the enclosure, and there was then room for the PMS to pop off this connector. And there were some suggestions in the chat about putting stakes or something coming in from the front of the enclosure, pushing back against the PMS to hold it against the PCB. I don't think that would help in this situation because it's already being sandwiched by the LCD that is sitting on top of it, and the front of the case is pushing against the LCD, which pushes against the PMS. The only problem, the reason mine wasn't working, is I didn't have the back cover on it, and it was all sort of flopping around loose. I think that all of these problems will be solved in the next iteration and with the cover screwed on properly. Yeah, so as Tinker said, so having the enclosure fully assembled may solve it. Yeah, exactly, that's my hope. And the enclosure is in two parts. So you can see the back cover there with the USB-C connector. The next update I need to make to this enclosure is to add holes on the back of it, here and here, for the two buttons. And do I have two different bodies? Yeah, so that is the back cover that screws on and clamps the PCB into place. And that is the front that it sits into. So if I hide the PCB, you can see that the PCB is sitting down on these little pillars. When the PCB is flat against those pillars, the LCD is being squashed against this inside face, and the AQS is squashed in between them. So by tuning the depth of these pillars, I can control how much pressure is put in sandwiching all of that structure together. So I just need to get the length of those pillars right, and then when the back is on and screwed into place and holding it, everything should be nice and secure. So I think that'll be fine. It just needs some little final tweaks and testing for the design. So I'll print we'll test the one that I just printed, and I need to make up some of the updated PCBs with the buttons that come out the back. Then I can send one to Austin. So Austin, hopefully, in my goal is, yeah, I want to get this project to the point where I can say, yes, it's done. And that is now gated on me assembling the most recent version of the PCB and putting the holes in the back of the enclosure. And because your firmware is already done, it's all working, I think we can then declare this project to be complete.
Found a photo of close-up photo of the screen if you wanted to switch it over. So
yeah,
there's a nice up-close photo for people to see, where it has the temperature shown, you got your humidity level, got some nice icons showing. You can see that icon assembly for the CO2E and BVOC, and it's red right now, so it means the accuracy is 0, because there's no values. If there were a value and it was still red, the accuracy is a 1. If it's orange, accuracy is 2, and if it's green, accuracy is a 3, which is the highest I've ever seen it go. You got your PM values, and you'll notice the PM values, the PM1 and PM10 are blue. More specifically, they are Superhouse blue, because all the colors used are the Superhouse colors for normal conditions.
I hadn't even noticed that.
And then because PM2 is within its warning range, it is yellow, matching the gradient yellow used in the border. So like if you're wondering why the color looks weird as it's getting to the edge, it actually does have a gradient border. It's not as bad in person as the photo might make it out to be, but it does kind of have a nice gradient going to the edge of the screen. And obviously that would go red if the value is worse, but any value that changes that is the cause of the border changing also changes the text. And while that number isn't very human readable in this photo, it is very much readable in real life.
Yep. Great. Oh yeah. So Tinker said that yellow number is a little hard to read. Yeah. Well, I've got one in front of me right now, which has the PM10 value in yellow, and it's definitely not as contrasty as the other colors. I can still read it. It's
I could always make adjustments.
It does look fine. Yeah, I can confirm it looks a lot better on the real LCD than in the photo of the LCD, which doesn't represent the colors properly.
We also have the splash screen, so that's what shows up on boot. It'll stay on boot until you're connected to your Wi-Fi, so the Wi-Fi logo sticks around until it's there. And then you also have, this is that menu screen that's accessible via the button. And it shows up as well. So that's the data it all shows.
The answer to Stephen's question is it took 33 minutes and 39 seconds to print on the X1C. That was just the main body. That wasn't including the back. So if this design is finalized, what I will do is lay up both the main body and the back cover as a single print, so I can print the pairs of parts together, and I will print a few in different colors, and yeah. It'll probably take about, my guess is it'll probably take about 40 minutes to do both of those parts combined. Yes, okay. So does anybody have any other questions for Austin in relation to the AQS firmware or OXRS? I need to do another OXRS. Crispian says, I want one. I need to do another OXRS update. I haven't talked about it for a very long time, and there have been things happening with it. So
There's a
Austin,
few
perhaps,
things, but most
yeah.
of it is just been regular maintenance
Hmm.
and just allowing everything to mature. We've added the Home Assistant support for quite a few things, but for the most part, we've ironed out like all the bugs we could find. So now hardware just runs, and you don't have to fiddle with it. It's something that you should feel confident enough to run in your smart home and not have to worry about things breaking or needing consistent repairs or reboots or any of that.
Hmm.
So yeah,
Yeah, well, I run it here in the lab. The light switches around here are connected to an OXRS light switch controller and different devices. And to be honest, I never even think about them. It never crosses my mind that I might walk up to a switch and it won't work. It's been absolutely rock solid. So yeah, great work from everybody that has been putting that system together. It has been quite a while since talking about it though, so perhaps one of the upcoming things we can do in the nearish future, Austin, is you could come back on and we can talk about OXRS related things.
absolutely.
Great. All right. We are now half an hour over time. So, Austin, thank you very much for coming on the stream. And now I have, because this is an even more screwed up stream setup than usual, I have to figure out how to actually end it. But yeah, thank you for all of the work that you've done on the firmware for the AQS and for OXRS in general. And also thank you for the streams that you do and sharing your own projects.
Of
I
course.
learn a lot from the things that you do.
That's why I try to do those streams is you always get that disconnect of, oh, how long does it take to really do these things, and why do you put certain design considerations in? So like I get people aren't going to sit for a full 8 hour thing, but you can easily pop in, ask a few questions, um, and learn some stuff, but also see, hey, I'm doing this particular item many, many streams long, and that's why it's taking this long.
Mm,
And obviously, I tend to walk through a lot of design considerations of why I'm using this part and why I'm placing it the way I'm placing it. So
mm,
that's why I do
yeah,
those streams, is to kind of fill that niche aspect of DIY and building things.
yeah. Okay, that's great. Thanks, Austin. I'm going to, what am I going to
Find
do?
the end
Hit the
button.
button. I'm going to find the end button. So I'll have to take you off screen first. And thanks to everybody else for coming along. This has been really fun and interesting. Yeah, I enjoy these sorts of things. It's getting into the technical aspects of how things are done. So yeah, I will see you all next week. Oh, one thing. Next week, there is a scheduled power outage here in Bayswater. There is going to be no power for at least part of the day next Sunday, right when I'm meant to be doing my stream. However, I have a laptop, I have a 4G internet connection, and we'll make it work. But just a forewarning that there may be technical challenges that I have to deal with to get the stream happening next week. So yeah, hopefully it'll happen. It'll happen. All right. Well, thank you very much. I'm going to do a very brief exit and I will see you next week. Thank you. Bye.